The notification to captain form, or NOTOC, can be produced in two formats: a handwritten or typed Qantas printed form, or the more commonly used computer-generated form. The header includes the port where the load originated, the flight number, the date of the flight, the registration of the aircraft, and the name of the person who prepared the NOTOC for load control. The station of unloading shows where the dangerous goods will be removed. This column will reflect multi-sector loadings. Each individual item is listed on the NOTOC with the following information: an airway bill or consignment note number. This is similar to a passenger ticket number, but it applies to a cargo shipment. A baggage tag number may also be displayed where dangerous goods, such as wheelchairs with spillable batteries, have been loaded. The proper shipping name. This is the name used by IATA and ICAO to identify the article or substance being transported. These are listed in the Dangerous Goods Regulations. Some of these names are generic. For example, the proper shipping name, consumer commodity, is a standard proper shipping name used to describe items such as toiletries, which are packed in a form intended for retail sale, personal care, or household use. The class or division number, and, for explosives, the compatibility group number. These numbers are synonymous with the proper shipping name. They are listed in the regulations together with the classification numbers defined by IATA or the UN. A subsidiary risk will only be indicated if the dangerous goods have more than one hazard. The next column indicates the number of packages being shipped that contain dangerous goods. The net quantity, or transport index per package, indicates the weight of dangerous goods in each consignment. For radioactive consignments, the transport index will be indicated. This number is used to determine the separation from passengers and crew, or cargo, which could be affected by radioactive emissions. Radioactive categories indicate the three hazard levels of radioactive goods. Note that where the category is 1, a transport index of 0 or nil will be indicated in the preceding column. Packing groups show the hazard level of goods that are not radioactive. These only apply to classes 3, 4, 5.1, 6.1 and 8. The cargo IMP code is the universally recognised code indicating the class of dangerous goods. The cargo aircraft only column should never be marked if the NOTOC has been prepared for a passenger aircraft. The next column indicates where dangerous goods are stowed. On wide-bodied aircraft, it will be a ULD number or hold 5. For narrow-bodied aircraft, this could be a barrow number or left blank. Load control allocates the location within the hold of the aircraft that the cargo or ULDs are loaded. Accuracy is critical because segregation from other dangerous goods, live animals, foodstuffs, or photographic film is taken into consideration. The ICAO Emergency Response Drill Codes give response information to flight crew in the event of an emergency. A summary of these drills is located on the reverse of the NOTOC and on the laminated segregation chart found in the flight deck multi-file. The lower half of the NOTOC provides information on special loadings which are not dangerous goods. These may include items such as human remains, live animals or perishables. Some of these items may be packed with dangerous goods such as dry ice. In such a case, the dry ice would be listed in the dangerous goods section, and the perishables it is refrigerating would be listed here. For domestic operations where no dangerous goods are being shipped, a load plan is always provided. This informs the crew of any special loads on board. The signature at the bottom of the form is that of the load controller responsible for the aircraft's loading. Once the pilot in command has accepted the NOTOC and agrees with the manner in which the aircraft is loaded, the pilot will sign the document and retain a copy. It is an ICAO requirement that a second signed copy is held in the flight deck file at each port of departure. It's also important to note that only one NOTOC should be held on the flight deck for each sector. At each port, a new NOTOC showing all transit dangerous goods and special cargoes must be produced.
The New Zealand Code of Practice for the Transport of Hazardous Substances on Land divides them into 9 classes. Each class represents a particular hazard which has been given a distinctive class label. In this video, we will go through them one by one, so you'll understand the signs you'll be seeing every day in the workplace. Chemicals, handled the right way, can be of great benefit to us and are sometimes fun. On the other hand, now, these 2 chemicals were in separate boxes for a very good reason. If he had been familiar with the code, he would have understood the labels and the risks. This segregation chart would have told him that a Class 3 substance must not be loaded with a substance classed as 5. An understanding of the code is vital if you're engaged in production, packaging, storage, dispatch, transport, use or disposal of hazardous substances. Some chemicals and goods can be hazardous by themselves and should be handled strictly according to the code. Some substances are extremely dangerous by themselves and must not be transported. Let's start with Class 1, explosives. The most dangerous explosives are those that will go off at the touch of a feather. Dry picric acid, for example. Then there are explosives that need to be detonated. There are also chemicals like ammonium nitrate that explode when they are mixed with fuel and then primed and detonated. Class 2 hazardous substances are gases. One supplier's catalogue lists over 80 different gases compressed in cylinders. Acetylene is one of the most common industrial gases, but it is highly flammable and should be used with caution. Make sure cylinder valves are properly turned off. Non-flammable gases also have their dangers. If you knock the top off a cylinder, even one containing something as harmless as compressed air, it could take off like a rocket. We will demonstrate this by using a small cylinder of butane. But remember, a large cylinder might go through the wall. Now we come to poisonous gases. Some of them, like chlorine, can cause death in just a few minutes. Let's see what happens when we put a plant in an atmosphere of oxides of nitrogen. The same thing can happen to you. Class 3 hazardous substances are flammable liquids. And the rule is, the higher the flash point, the less likely they are to catch fire. Kerosene has a high flash point, so it's impossible to light it at room temperature without a wick. At the other end of the scale, we have acetone. It has an extremely low flash point, which means it ignites very easily. Class 4 includes flammable solids and substances which are spontaneously combustible or dangerous when wet. A flammable solid like magnesium ignites very easily. That's why it's used in flashbulbs. Watch what happens when a strip of magnesium is exposed to a flame. Chemicals like phosphorus are spontaneously combustible and can catch fire when you least expect it. A solution containing phosphorus has been spilled. He thinks he's wiped it up. Just wait until that dries out. Some solids burst into flame when wet. Potassium, for example, reacts with water to produce highly flammable hydrogen. Class 5 includes oxidizing agents and organic peroxides. Oxidizing agents can cause uncontrollable burning, and they are sometimes found in products you might have around the house. If pool chlorine is left in contact with sawdust long enough, it can generate enough heat to catch fire. It is likely to ignite sooner and burn more fiercely when oil, terps, or brake fluid are also present. Some organic peroxides are so volatile at room temperature that we can't demonstrate the hazards for you. If we took a bottle of isobutyryl peroxide out of the freezer and then shook it or struck it hard, it could explode. Class 6 includes poisons and infectious substances. They are usually absorbed through the skin or inhaled. Oxalic acid, which is found in rhubarb leaves, is very poisonous. It is also found in a product that removes rust stains from boat timbers. Poisons can also be swallowed accidentally. You can get more than indigestion from a pesticide sandwich. Fats in dairy products can readily absorb toxic vapors and substances. This is a label used to warn of the presence of microorganisms that cause disease. Handle strictly according to the rules. Class 7 materials are radioactive. They emit invisible particles or rays. Exposure to high levels of radiation can cause illness or death. The higher the number, the higher the risk. Radioactive materials are more commonly used in medicine and industry than you might think. Class 8 hazardous substances are corrosives. This is what happens when a piece of cloth is dipped in nitric acid. Don't let corrosives get on your clothes. Aircraft structures made of aluminium alloy can be badly corroded by battery acid, mercury, or caustic soda spilt as a result of poor packing. And don't think corrosives only eat away at cloth or metals. They can eat away at you and me. Watch what happens when the meat goes into contact with battery acid, which is at body temperature. The same thing could happen to your skin. Class 9 is miscellaneous dangerous substances. It includes substances such as dry ice, dried ice may seem harmless, but it can stick to your hands, especially when they are wet, and give you frostbite. So far, we have dealt with the major risks. These are indicated with a class label with a number in the bottom angle. In the case of nitric acid, this tells us that the major hazard is corrosion. But nitric acid is also an oxidizing agent. This is known as a subsidiary risk and is indicated by a label without a number. And finally, a word on packing. It is important to pack hazardous substances in the right material. For example, fuming nitric acid should not be packed in cardboard boxes. Surrounding it with sawdust is another mistake. If the fuming nitric acid leaks into the sawdust and dries it out, a bump could be enough to ignite it. So, the moral of the story is, know the class labels, follow the segregation rules, and always...